Good evening and a very warm welcome to all who are present here and to all who will be watching this recording later on. Welcome to Walk the Talk, a series where I talk with leaders and have a conversation with them, leaders who walk their talk. And today I am really fortunate to have with us Jaspreet Sethi, founder of Math with a Smile and a mom. She works with schools to build and nurture curiosity, resilience, creativity, joy, thought, humaneness, and discovery in mathematics teaching and learning. She has a master's in mathematics education from Teachers College, Columbia University, and has served as the department chair for middle school mathematics at the Birchwathen Lennox School, New York, as well as on the advisory board for teacher education at Teachers College, Columbia University. Jaspreet has worked in the field of education with various age groups for the past 17 years and is well versed with the curricula and schooling systems across the globe. She is LETRS certified and is currently working on authoring a series of children's books. Today, I feel fortunate to have you with us, have you with us, Jaspreet, as you share some ideas for developing a fondness and mindset for mathematics. So this is actually the need of the hour for all of us, whether be a parent, a teacher, an adult, everyone. We all need that, when it comes to mathematics, it's not a subject, it could be an emotion. So we need to have that mathematical mindset to deal with the challenges that are faced by so many of us. So without much ado, it's over to you and very warm welcome to you, Jaspreet. We're very fortunate to have you.
Thank you so much for the very warm introduction. And if I may say, I waited all this while to speak because you were a teacher of mine. And now the student is taking over a little bit to share her thoughts. So thank you so much. The honor and the pleasure is mine. I wanted to take a quick minute and ask everybody, am I audible and is my screen viewable by everybody? If you can just put that in the chat or give a thumbs up, that'll be awesome. Thank you. Thanks so much. Perfect. So I am going to be sharing ideas for developing a fondness for math. Yes. I always begin by asking my audience, my participants, a question that I've asked my students over the years. What comes to your mind when you think about the word mindset? If you can take a minute and jot down maybe one word that comes to you when you think about mindset. So those of you who have just joined in, we are thinking about a word that comes to our mind when we talk about mindset. This is a question I've asked my students over the years, and this is a question I am now asking all of you. So I have some people writing in the chat. Yes, programmed mind. Thank you so much, Ms. Nina. Feel free to interact, everybody, in the chat. Whatever comes to your mind when you think about the word mindset. These are a couple of answers that I have received over the years from my students. Positivity, thank you. And I'm going to share them with you. One word. Growth, awesome, thank you. So my students, when I asked them about mindset, said it means something to do with attitude or belief. Another thing, preconceived notions. Thank you so much, Mr. Matthews. And there's another student who spoke about aptitude being a word associated with mindset. Success, and what it means to be successful comes with how we perceive success and what mindset we are having for that. Some other words that came as a result of this experiment were ability, and another one that came in very often, more now than in the early years. Now I think the recognition is there that mindset comes with effort, the effort that we put in something. So this kind of ties along with a question that I've asked over the years. What is a mindset according to you, from my students? And some of you have shared your views as well. I wanted to now take you through some myths that are associated with math and math teaching that are so common across the board, and teachers that I train right now also end up writing some of these myths as the answer to the question, what is math according to you? So you may think about an answer. I will move forward and show you some of the responses I've received, which are all myths, by the way. First one is that math is all about speed and thinking and doing and answering it really quick. That's a myth. And I will be breaking all these down as I move forward. Another one that has come very often, or when I've asked students or children or teachers, what is math to them? And I've been told that being good at math means you possess the ability to solve questions and get answers, something along the lines of the first myth. But here they didn't thankfully focus on the speed part, but also a myth. Another one, another student, another common response I've received is math means precision and accuracy. And a lot of points taken on a test or an assessment end up being related to this, where there's a computational mistake versus a conceptual one on precision and accuracy. The answer, the work was correct, but something was wrong in the final result or the solution. Another one that comes very often as a myth, as an answer, is math means being good with numbers and calculations, and this tells you that you're smart. Another one is a math person is one who is gifted with a math brain. And all of these in today's time are myth. Research has shown there is nothing known as a math brain. There is something known as a prodigy. There is something known as giftedness, that's right. But that can happen in any department, not necessarily math. And if somebody is really good with numbers, something has happened, some connections have happened in the brain over time that have allowed the students to be really good with making those connections. And that part of the brain is something that can be worked on. So my journey now would consist of two sections in this workshop. One would be, it'll be exactly what my topic says. One would be to say how to bring in the fondness as a parent, as a teacher, how to cultivate that fondness. And the other one would be how to nurture a mindset for math. And those of you who have worked with me know that I work with age groups pre-K all the way till 12th grade and beyond with teachers and parents. So I will be taking this time to address different age groups in math. So some of the material may not relate to you if your child or your student is a high schooler, but at some point I will be addressing some things that cater to high school and then do not cater to pre-K or primary or middle. So the first thing is fondness and how to nurture that. So I again start with some things which are kind of like myth busters that I want to start with. So everything you're seeing in red is something that I would encourage parents and teachers to not do. And then of course I talk about what should be done instead, which will be really helpful. So part one, which is fondness, is this connotation or this phrase we use often sometimes with our children. You are smart. They did something, they solved something, they did a Rubik's cube, they solved some puzzle, and one of the ways we applaud them or praise them is saying, oh, you're so smart, you got it. Another one that very organically ends up coming to us is something along the same lines. You're clever. Oh, that's so clever. And that's something that I strongly discourage, because I think what we're trying to set our children up by doing that is that when they are not getting something, then they feel not smart. Then they feel a little stupid. And that is something that I am trying my best with the work I'm doing to eradicate. That smartness can be cultivated. And I hope kindness is something that is put far above intelligence. And of course, intelligence is nice to have. So what to do instead? What would be counter thing to be done? Well, one of the things is to say you tried, to applaud the effort, that you're so happy that the child tried. It's not easy to um, leave your comfort zone and do something that may not be your forte, your skill. To actually take something up is applause and praiseworthy. So you tried instead of you are smart or you're clever. Another one that I love to use with my students, with my children, is you kept going. I am so proud of you that you kept going. Because this happens that we reach a stage where it gets challenging. It was all fun and games up till a certain point, up till primary and maybe possibly middle school. And then it became hard and challenging. And that's where we see a lot of children kind of like, the grades falling down, interest falling down. So to applaud someone who's actually sticking to doing something that's hard is something that I would strongly encourage all parents and teachers. You kept going. The other thing that I wanted to talk about as we talk about cultivating fondness would be, there's this fixation. It's very common in early years actually to target 1 to 100 or just jump to higher numbers. Now see, my child can count like up till 100 and backward counting, and they know how to do like thousands and now go to 10,000 and so on. And there's this fixation in the early years, especially. And when I'm saying early years, I'm referring to anything where your child is 2.5, 3 years old, even all the way up till as they're getting into school or like in first grade or second grade. There's this jump, even in curriculum, that let's just now like now they've mastered the ones, the tens, let's go to the hundreds and let's go to the thousands, let's start doing addition, subtraction, multiplication with these higher numbers. And that's something that actually I would encourage teachers and parents to slow down. I wouldn't say stop doing, but slow down. What should be done instead actually is to really solidify 1 to 10. And a lot of people here are going to, when I say this, going to be like, yeah, but like, what do we do after they know their numbers? Like, they know how to count. What do we do? Actually, counting comes so much later. Visualization of math is so important that the child can really see what they're doing. Say when they want to do 5 plus 8, which as an older extension problem would be 50 plus 80, and then becoming a decimal or a fraction value. To have a good sense of numbers, children really need to, I will encourage everybody to please mute themselves. Thank you.
1/3 வராதுல்ல 1
Maybe,
தானே
maybe I'll help
1/3
in
மாத்தன
this process. Okay. I hope I am audible to everybody. So 1 to 10, and how to go about that, even if counting has been done. I just want to take a minute and just check if am I audible to everybody? If I can just get a quick thumbs up. Awesome.
Yes, you are.
Thank you so much. All right. So 1 to 10, what do we do? So I'm going to actually start with something which is I'm jumped to 6. Just for fun, I'm showing different representations, multiple representations of the number 6. So these are called partners of 6. I'm trying to show 2 and 4 on a dice. And when you see dots and you're able to actually understand what the number is without counting, this is called subitizing. So it is a concept that should be taught in the early years in pre-primary, primary, to get children to be able to understand what this number is when I am joining or connecting or doing the sum of these two dice. This is 2 and 4 added together, and that's 6. And again, some other representations of partners of 6 I want to show. So that was using dice. And now I have something known as unifix cubes. So I'm trying to show 6 and 0, 0 and 6 property in math. The other way to show 6, 2, 2, and 2, 3 groups of 2. Other ways, and this is, by the way, from the beautiful book by Eric Carle, The Very Hungry Caterpillar. Some other ways to show 6. This is called a 10 frame, and I'm trying to show 3 and 3, 2 rows of 3. Other ways to show 6, using tally marks. So I have popsicle sticks, and I'm using that to show 6, 5, and 1. I also use my fingers a lot when I'm trying to get the child to understand numbers. It's sometimes not easy for young kids to actually open their hands because of their gross motor skills and motor skills. So I encourage the use of a glove or a hand cutout to fold the fingers and get the child to do that with their hand or a cutout of the hand. Other ways to show 6. I have many ways to show a particular number. I have a hexagon, and now I have covered it with a trapezoid and some triangles. And I could have used 6 triangles, yes, to show the number 6. So if we can do multiple representations of a number within 1 to 10 and look and talk about partners of 10, partners of 6, partners of 5. Partners of 5 would mean something like what I just did with 6. Partners of 5 would be 2 and 3, 1 and 4, 5 and 0. If we do that with our younger kids and even the elder ones, because when it's a probability problem, when you say the probability of something is that for rain, it's 8/10, what's the probability that it will not rain? What are we really doing? We are getting our child to think of a partner of, in this case, 1, a much smaller number. So understanding the number, where it is on a number line, what is the magnitude of that number, all of that is way more important than trying to get the child to do 1 to 10 and then 11 to 20 and move on and move on and move on. Writing, of course, writing the numbers is nice. This is one of the very basic ways in which we need to spend some time talking about how the numbers are formed. And there are tons of videos online about this. I also talk about to high school teachers about this. Actually, they may think that this is not related to them, but when we have a lot of errors, computational errors that our students make in their assessments on their homework, sometimes the errors are because of the children not writing the numbers clearly, the digits clearly. Sometimes the 4 looks like a 7, looks like a 1. Sometimes there are these issues, and subsequently there are so many other errors that end up
हाँ
coming.
अभी तो टाइम ही लगेगा एकदम छोटे मोटे
So for that reason, I love my and I encourage my teachers and my parents to focus on 1 through 10. And when we talk about counting, that's cardinal numbers. These are ordinal numbers. And we talk about again using 6 here. Circle the sixth person versus 6. Circle the sixth person from the left and circle the sixth person from the right. So that is ordinal numbers when we're talking about position. So not just talking about counting, but also positioning of values. Then move on to 11 to 20 with again some manipulative. I like to use popsicle sticks a lot or my Unifix cubes. So I'm trying to show 12 now, double of 6, using 10 plus 2. And here again, I'm showing tower of 10 and 2 loose blocks. A lot of virtual manipulatives are available online. If anybody is interested, I'm happy to share how I get some of these which are not physical online after the presentation, or feel free to contact me. These are Unifix cubes, and I'm trying to show now 2 tens and then graduate to 20 and onwards and onwards. Again, the relationships within the numbers are really important. Within 20, within 10 are really important. So another way in which I'm dealing with place value beyond 10 but under 20 is, for example, for 19 or any number you want to get your child to represent. So show the number using tens and ones, fill in the number sentence, make an addition sentence to represent that number. And it kind of really gets the child to really stick and see that that 19 is not just 10 and 9. It could be 14 and 5 and so many other ways in which you can make 19. So partners of a number is this concept. The other thing, which again for a mindset busting situation, would be the obsession with toys, gadgets, and apps. Find the right app for my child or find the right app for my student. I repeat this, teachers are the ones that teach. Apps, toys, and gizmos don't teach. It's the human. So perfecting our craft and our content is way more than finding that right way, that right online resource for your student. Of course, it is helpful. It is very, I'm not denying the use of technology in today's time, but what I am trying to say instead is what can be done instead would be that we focus on building some very fundamental skills in our students and our children. And one of those would be observation, to observe what's happening. If something is shown, something is out there, a shape is there, something is there in nature, observe the math and the beauty in it. So this is a fun game that I play with sometimes some math for little kids, and sometimes actually as high as middle and high school, where I'm teaching arithmetic progression or geometric progression. These are basically triangular. This is a triangular number sequence. There is so much math going on here, and it's all through visualization. I've not really put like this is my term and this is the position number. I'm not doing that. I'm showing pictures and I'm trying to go through a journey with observation, with simple counting, where my students can at this point predict what will the sixth triangle, sixth shape look like, or the seventh, and then take on a journey if needed in high school to talk about the nth term for a sequence such as this. Other observations, so this is Fibonacci. Those of you who are not familiar with it, this is a sequence, and it is so beautiful, and it's in nature. These are some aloe vera plants, and and not just aloe vera. There's some broccoli or some fancy broccoli. There's so much math in nature, and getting your student, your child, to appreciate and see and observe what's out there and how math is linked to it, which will come very gradually, but something that we can inculcate in our children from a very early age. When we talk about our galaxy, it is actually a Fibonacci spiral. If we this is a fun exercise that I got on from GMP Global Math Project, and this is actually showing the Fibonacci sequence again if you count the branches, what branch you're seeing here versus as you move from bottom to top. So 1 + 1 2, and then 1 and 2 3, and then 2 and 3 5, adding up. The beauty and the appreciation for nature, and where math is actually coming from and not the other way around, is something that I love to spot and show my students and my children. I was just walking the other day and I saw this, and this is a tessellation pattern. And there's so much math going on here. It was basically the floor tile. Another one, beautiful nature, again, hexagons. This is a honey beehive, and you can see the hexagon pattern there. So symmetry in nature, and seeing how beautifully things are so symmetrical when we're trying to teach symmetry in higher classes is something which is so eye-catchy, and it kind of really not just gets our students' attention, but also gives them a hook and a way to appreciate what you are trying to do here when you are teaching math, or introducing them to the beauty called math. I was doing a Pukalam with my child the other day, and we were talking about, again, symmetry. Or when there was a rainbow in our balcony, we talked about how that's a parabola. Of course, I mean, if there are higher education kids or secondary children, then there's so much math that comes out of that. When we talk about the quadratic equation, what could possibly be A, B, and C here, and then start finding the roots. So much is possible, and sky is the limit. The other thing I love to do with Funness is to really get my students, my children, to see patterns, my teachers to teach patterns to their students. So patterns start with something so basic and rudimentary, such as zebra pattern, like the stripe pattern on a zebra. But more than that, above and beyond that, beyond nature, when you start giving patterns, you are actually inculcating critical reasoning in your child. And I am doing this through shapes. So I have a square, circle, rectangle, and different colors. What's going to come next? Something with early years, but you can progress. You can progress to something higher than that. And that would mean something along the lines of table, the number of chairs around a table, and actually get this to happen. When we teach progression, we teach mean, median, mode, and range. A lot of times we just give the numbers and just get the students to calculate. Actually get them to stand height wise and see the median right there, that middle kid. or to see the range, or to find the minimum and the maximum. So much is possible visually, and it really sticks with students. So this would be one of the ways in which I would do. And this is one of my most beautiful things to show to people when trigonometry is taught. I'm just so sad sometimes to see these videos all over online and everywhere, where it's like there's a song for sine, cosine, and there's a rap for it in today's time. There's a way to memorize it. Okay, cool, maybe good to reproduce back on a test or something. But I hope we can see the beauty here. This is the sine wave, and it's found in sound, in music, in everything. Also, when you're having a circle, a tire, you're driving, your tire is moving, it's showing. I mean, it's that sine wave is getting formed, and a little shifted. A version of that is your cosine. And where is tangent coming from? It's all so visual. And if these are brought into the classroom, this would be really good use of technology, I would say. The other thing, which is kind of misused a little bit in today's time, I feel that it's like a lingo or a jargon now, that yes, play is so awesome, we should get our kids to play. Yes, I agree, I completely agree. I think I was the first one who kind of as an educator, in my time, propagated play. Yes, I completely agree, but it has to be done with some thought. And every game will not be a teaching experience. Understand that as well. Sometimes the game is just for review, and sometimes the game is to really get the students involved in, or to break the monotony. It's not always and always that everything can be fun and games, and that's life. We want to play and we want to have fun. And I think I talk about some ways in which play can be done very effectively, but also we need to kind of, have this balance of having a class which is so engaged. I think that would be a better word than to say that we should be playing in the class every time, or gamifying everything in the class, which is very hard to do, and I get it. But I give some ideas over time. I have also come up with a range of things that can be done, but I would uh, say this with a pinch of salt and with some caution, that everything cannot be gamified. And here are some ideas of play. With that being said, that's playing with blocks to begin with, making a pyramid. Let the child do what they want to do, let them knock it over, it's okay, we'll start all over again. And that's fine. And as you progress, yes, please, if you're thinking about toys, please go and invest in some Legos, some Unifix cubes. These are Unifix cubes, and they're so useful in a lot of math I teach, from primary all the way till middle and high school. When I'm trying to teach um, isometric drawings or top view, front view, it is such a hard concept for some students sometimes, and I actually build something with them and get them to see it from different angles. So these are good investments to make when it comes to toys. Or make the toy. I made a spinner. I used the fidget spinner, and I actually made that, and I was teaching probability with this, and I was also playing games with my students. And you can teach pie chart. There's so much that you can do with all of these tools that can be created, which take some time and investment, and that's always required in anything we do. Puzzles, this is another thing which is kind of overlooked over time. Some people are really good at puzzles and building blocks, but a lot of times we kind of overlook this very, very useful and such a therapeutic thing actually for some people. So puzzle pieces, starting from, and in today's time there are so many good things, like for a toddler there are 4-piece puzzles and 6-piece puzzles, and then they graduate to 1,000 and plus, depending on the age. But please don't just bring a box and just give it to your child and say do it. You need to sit, you need to show how the pieces fit in. Sometimes you need to show how to start the puzzle, how to identify which pieces might go together, how to first put the corners maybe. um, it takes time, it takes investment, and it takes a lot of effort to inculcate this fondness for puzzles. This is one puzzle which I have been doing with my child, and this is a logic puzzle, and it's called Mini Look. And I'm so grateful to a beautiful person who actually introduced me to it, and we actually got it. So this is one, and there are many out there. You'll Google it and you'll find age appropriate puzzles. Reading, which is kind of overlooked sometimes in maths. A lot of math is language. We talk about word problems or critical thinking. It comes from being able to decode what is written. It's not just numbers after a point. There is a lot of information when it comes to problem solving, where we have to decode what has been given and then translate it to a mathematical solution. So there was a student who was having a tough time with this. This is, I think, first grade. There are 8 birds and 2 worms, and how many more birds were there than worms? When we put this, we say, "Oh, this is a subtraction problem. You just have to know this." Well, but then the wording more is confusing for students sometimes. So I actually reworded the problem, and I said there are 8 birds and 2 worms, and how many birds will not get a worm? And it just made that connection like right away. For that particular student may still not make it for some people, and that's okay. And that's why we have to be creative and show it and use manipulatives and draw it, make those birds, show those worms, bring in anything to show that a bird is having worms, and then how many do not have worms. Some other ways which can kind of progresses to high school is when there's so much wording and you have to make sense of that, and that's where we use so many mathematical tools such as this one. We need a Venn diagram. We need a Venn diagram to be able to solve this. And it's never too early to show your child a Venn diagram, actually. Not maybe the 3 circle, but the 2 circle is very, very simple. At a very early age, when you're teaching your child similarities and differences, compare and contrast, even in an English class, a Venn diagram can be used to show what's common, the intersection, versus A not B, B not A, all of that. There are a lot of books out there that actually are very rich in math, and I have just put some here. There are so many that again can be googled online, and I'll be happy to share some names later on. And the biggest thing I would say when it comes to fondness would be that you're doing math every day and every day. So English teachers will understand the difference, I hope, here, and explain it to all the others, that when we're talking about daily versus making sure that it is done routinely. So seeing math in everything, when you're doing grocery shopping, when you are shopping, or using money, a credit card, a debit card, when you are budgeting, you're going on a vacation, you are traveling, how much math goes into all the things that you do, or hire someone else to do, such as your taxes, maybe. So involving the children in all these activities will definitely really touch some chord. I know that, and I've seen it over the years. And the most important thing with fondness, I would say, is the obsession with math, and just as a standalone subject versus making it multidisciplinary. So some examples of that I have would be along the lines of using history and timelines, and seeing the math there, in data. I'll show some examples of some cuttings I got from newspapers where I do a lot of math with my students on reading a scale, or in geography, reading scale drawings, reading a map, and how much math is being used there. Because of course, 1 centimeter on paper makes sense. I cannot represent the 25,000 centimeters that is in reality. So drawing to scale and how much math is used there in another discipline. Uh, these are some cuttings that I have gotten over the years, and I'm seeing so much math here where there's a spike in because of heavy rains in the vegetable prices. And at one point with COVID and active cases, there was so much math that can be calculated, percentage change, you name it. I mean, you're representing data, but you're also analyzing the data. So these are some of the ways in which I would talk about the fondness part. And now I am going into the mathematical mindset part. And for those of you who are looking at the clock, I would say this would take another 10-15 minutes really. And I will be happy to take up questions after that. So mathematical mindset, I talked, my part 1 was on fondness, and that can be inculcated by teachers, by parents, by families, by caregivers. Mathematical mindset is such a self thing, but again, seeds need to be sown by somebody. So here is where a lot of teachers can make a lot of change. And of course, with the fondness part also, there were a lot of teacher ideas. This is actually true. My one question to everybody as a teacher here, an educator here is, and I will relate this to math, how do you show your humane side in the math classroom? How do you show you're a human and not a calculator? And ways in which I suggest, and I think are some ideas that I have used over the years, which have been very effective for me, would be to share your life experiences, to share how you have shown patience over the years in trying to stick to something, in trying to build your own stamina for something, how you have inculcated attitude in trying to still learn. You're still learning, you're still here today. And this workshop is not for, okay, I just had somebody tell me that if I'm showing something, this is not visible. Is that true for everybody? Are you not able to see my screen?
We can see question number 1. How do you show your human side?
That's exactly what I'm trying to show. Thank you. Thank you. So how do you show your humane side? How you are still learning as of today. You still do crossword, you still do Sudoku, you still do some puzzles. How do you still keep it going? What is the gratitude you have? How do you appreciate the teachers who really stood by you and who really did not give up on you? So how do you show your humane side? How do you plant? Do you cook? Do you sing with your students? Do you play music with your students? There's so much math in there, and everybody who cooks and recipes and fractions knows that. Proportional thinking. How do you spend your free time as a teacher? How do you solve a difficult problem without losing your cool, without saying, oh, this is so hard, but then saying, okay, but I'm going to try, but I'm going to give it a try? How do you do some math on a tissue paper or a napkin? How, that problem you want to solve right there, and how you praise and applaud your students' work and effort, and how you do not say you're so smart and you're so clever, but instead say you tried and you kept going. And how you celebrate their mistakes, how you show them that mistakes are so important for making the mind grow. And mistakes are the ones that are really the learning paths for us. If we did something right, we just move on. But when we make a mistake, that stuck-upness is very important, to kind of reflect and see how to do it better next time. The other question I have for teachers on how to cultivate or nurture a mindset for math would be, how do you help your students navigate hard? So I usually give an anecdote here with my own child. I'm going to skip that right now, but I will give some ideas on navigating hard with some things we can say to our students, to our children. One of the things is that it gets challenging, and everybody, us included, want to give up on something because it's getting hard. And now we will be out there in front of everybody showing that we are not that good or not that great. So a mindset for our own self would be, or a mantra for our own selves would be, I am going to train my brain. I'm going to train my brain to really get it. And sharing with our students, remember when, if you've been teaching them from a long time, or if you can bring in teachers from their early years in a high school classroom and say, remember when you used to do that? Those are actually not avenues for shaming the child. No, those are ways in which we are telling the child, let's see, so look how far we have come. You know, you were not at some point able to do ABC, and now you're able to do XYZ. So look how far we have come. And of course, other ways in which we can say this would be something like, what am I missing? Or let's use a different strategy, and acknowledge that this is hard. Sometimes we end up saying as teachers, oh, but this is so easy. It's easy to us because we've been doing it for so many years. We need to put ourselves in those children's shoes who are seeing something for the very first time. You may say and acknowledge that this is hard, I know, but we're going to train our brain. We are going to find the most efficient way of doing it, because we know there are these 10,000 ways of doing it, but we're going to find the most effective way that will work every time. Or yeah, I know it's getting challenging, but we are going to try. We're going to give it our best, and we are going to make sure that we make a lot of mistakes, but not the same one twice. So mistakes help the mind grow, so they're really good. And also, this may take some time. Sometimes, you know, in the world we live in, everything is so instant. So instant gratification is such a thing that it's not happening. So I just put my pen down, my pencil down, and that's it. But actually telling, you know, when it comes to planting something, and that's why I say plant with your child, to see how every day, little by little, incremental changes, which is all what calculus is, incremental changes is how anything really happens. So this may take some time, and we can all do better. So those are some phrases that you may use with your students on how to navigate hard. This one is kind of sort of my favorite, because I kind of get everybody involved now a little bit, I think. How many of you know what is a neural network? Some of you may be from a computer background, maybe, and you may associate it with computers. And actually, yes, there is a connection. This neural network that I'm talking about is our brain, and how we make connections with the neurons in the brain. So this is a quick game I like to play with everybody. And you can join along. I'm going to show you something for exactly 10 seconds. So for 10 seconds, I'm going to show you something, and it's almost like this memory game. So you have to recall, and you may type in the chat like what you remember out of what you saw. Okay, so this is for 10 seconds. My timer has begun. You're not writing this down. You are just capturing it in your mind. And my 10 seconds are up. So you may take a minute and start jotting down in the chat what you remember you just saw. I showed you 10 objects. Does anybody remember what they just saw? I know it's so quick, right? This is what we do in class sometimes. We present something for so short a time and just move on and expect our students to just get it. Ah, Deepti, thank you. Wow. Okay. Yeah. A lot. Yeah. Good memory. Very good. Does anybody have all 10? Does anybody remember all 10? Sambhaya. That's right. Yeah. Pretty good. I would say it has to be Deepti for now. She has like 6 out there out of the 10. Deepti's still typing now, new things. Meena has put a lot of other things. Urvish, sorry, had put a couple of things. Some of you are repeating the same things. Good, very good. So what am I trying to do here? Of course, where's the math? What I'm trying to say is that when we put isolated pieces of information in our child's system, in their brain, and we expect the connections to be just made without us explicitly sometimes making those connections very evident, we will see a difference between the child having short-term memory or working memory versus long-term memory retention. So some people are very invested in this game. Thank you. You're still playing. I'm going to go back really quickly and show you for those of you who were actually, you were really good. Yeah. What's missing? Some of you can now see. Yes, somebody did not write a neck pillow or the charger. What am I doing here actually? This is the process for me going to the airport. So if I build it into a story, you will actually see and you will be able to retain it better. So I have some snack. I make sure that I have my neck pillow, a headphone, some kind of a puzzle to do. I have made sure that I have weighed my bag, my luggage. I have my charger. I have my passport. I have my book. I've locked the house. When I do that, you can, through this story, have a better recollection of all the items that I showed you. And this is what I'm talking about when we're talking about building or strengthening the neural network for children. How many times do we go back to prerequisite skills that our children need to study or to understand a new concept? How many times are we checking in our curriculum if the connection from chapter 1 to chapter 2 is smooth? Maybe there is no connection. So how do we build that connection? What is the prior knowledge that we need to activate to build new knowledge? So how do we stimulate active learning and how do we reach them all? And this would be the last part of my presentation, which will be another about 3-4 minutes. So this would mean that we are saying some of the right things and doing some of the right things in the class. So I already gave some examples of saying, but I'm going to give some more examples of saying actually. Some of them would be, which is very, implicitly explicit sometimes. Give clear instructions in the class, giving very clear instructions of what we are trying to say, record ourselves and actually get somebody else to reiterate what we said. And sometimes it ends up being almost like Chinese whispers. The message is lost. So giving clear instructions, repeating back, getting your students to rephrase what you said, chunking, breaking down the task into smaller parts, teaching our children organization. This would be an example of a T-chart. You may use a flow diagram, a Venn diagram, a concept map, a mind map, a KWL chart, a Freer model, any of those. I'm trying to show integer here and actually teaching our children using graphic organizers. These are called graphic organizers. Using graphic organizers, teaching our child how to organize their notes, how to put it in words, how to go back and reflect on the notes, what they write in a class. And not blindly write anything and everything, but what is important. And it's also important that you are, as a teacher at that point, not speaking and getting them to write and getting them to listen at the same time. It is impossible. If you're speaking, then let a visual be there, but not cluttering it with cognitive overload. This is cognitive overload right now, where you're having, I'm talking, you're seeing, you're trying to write this down, somebody's trying to take a picture. There's a lot going on. So I'm still on saying some right things. So boosting their self-esteem, posing good questions. It's not just about who can solve this, but how do you know? How do you know this? Or how can you tell? Or how can you show this? And can you spot the error? Actually, purposefully make mistakes on a test, on an assignment, on the board, and get them to spot the error in that, and that really activates critical thinking. What's a common mistake? A very common mistake in algebra is something along the lines of this. I'm going to do a little bit of annotation here. This is such a common mistake. I do something like this and students do that, and that's not correct. So why is it not correct? To actually show them ways in which you can plug in any value for x and see is that value going to be just x again if you do that? No. So what are some common mistakes? What are some common myths? I think in doing this, I just ended up stopping my share. I'm going to go back to my share. I realize that. And doing would be presenting visuals, which I think I did plenty. Relatable content, having content that the student can relate to. Sometimes you may have to change the word problem. Maybe it's outdated, maybe it's not done anymore, maybe the price is not right. The using graphing organizers, reducing cognitive overload. When I said, how there's so much on the screen that it's hard to visualize, and differentiate, stir the pot a little bit, do group work, a lot of group work, collaboration, get students to critique each other and convince each other, or reason with each other, discuss and present and show mastery of their subject and the topic that they have, the fluency that they have received in that, and reflecting on that would be some of the ways in which I would say that we need to activate learning. So as I am wrapping up, and before I take questions, I just want to have a really quick analogy with broccoli and potatoes. So I am putting this out there, and I will give you some gyan, which everybody knows maybe, that broccoli contains high levels of both calcium and vitamin K, both of which are important for bone health and prevention of osteoporosis. Broccoli is also full of other nutrients like magnesium, zinc, and phosphorus. And imagine giving this health manual like information to your child and saying, here, eat some broccoli. Your child is not going to be eating broccoli by you giving all this gyan. Your child will eat broccoli if you may teach your child to appreciate new foods, try new foods. And also if you, as the cook or the person giving the broccoli, mixes that with familiar foods and tastes and textures of things that they like already, like potatoes, maybe. And being persistent to present broccoli in creative ways, maybe as a cupcake. I don't know, there are a lot of recipes out there for some very interesting ways in which you mix some very healthy foods, and kids may learn to value broccoli if we praise their efforts to try some broccoli no matter how much they don't like it. And then I replace this all with math. And I also talk about this thing about potatoes, where I say that if kids love potatoes as kids, hopefully they will still love potatoes as adults. And they may get tired of eating potatoes in a certain way. So we need to mix it up with other veggies, gravy, salad, seasoning, and that means multidisciplinary math. Hint, hint. And they may become may not actually become expert potato chefs or potato experts, but they will be always looking out for cooking or appreciating a well-made potato dish. And not every dinner table conversation needs to be about how important the broccoli or potato is. Sometimes let them just enjoy the potato and give them reason to come back for more potatoes, and replace it all, copy, replace with math. So this is where I end my talking. I would love for you to take some time to reflect on ways in which you will nurture some fondness for math out of the ideas I've shared, or that you explore over time, how you will develop a mindset for math, and what are some takeaways from today's webinar. I would love for you to share in the chat or in person. I will hand it over to Miss Nina now. I've done enough talking. Thank you.
That was an amazing share. There were so many takeaways. I mean, right from starting of mindsets, the myths, the remarks. I mean, we have the habit, as a teacher, we have the habit, you are smart, you're clever, but then where is the grit? So, you need to make children gritty about mathematics. And that's what, throughout the presentation, I could feel that, not giving up on this entire subject. So that's what we are looking.
Miss Dean, I'm sorry. I
Oh
think you were
my
unmuted for a
God.
second.
I
No,
was
it's just the last word I think you said. We heard every part of what you said.
okay. Yeah, so it was just amazing share that right from the the mindset part, uh, breaking the myths, the remarks, everything that you shared was really amazing. And what we are looking for is developing this kind of grit in children towards this subject. I don't like addressing mathematics as subject, because it is not. It is something in our life. I mean, it's there, like you said in your presentation. It's every day. Like, how you there's no escape from this. There's no escape from numbers, from designs, from patterns, from observations. Everything that you shared, it's there. So why not make it a routine in our children's lives, in our lives, with not just the textbook or pen, paper, and they're sitting there. But when we are traveling, mathematics can happen. When we're going on a holiday, when you're driving, I mean, everywhere it is, you just have to look for those opportunities and you find mathematics. And it was just really good what you shared. I have noted down so many things, Jaspreet. It was an eye opener for me too. The toys that you said, I mean, subitizing, using those partners of numbers, initial years, that visualization of mathematics. That's again an amazing thing which needs to be focused on. Visual thinking in mathematics has to uh, it reinforces all the concepts. So thank you so much. I really, I can go on and on, because I was all ears, all eyes throughout your presentation. And I have my special notes with me, which I'm going to use definitely. And others who had joined us, thank you